on this frontier are efficient, right? There is no more efficient or less efficient portfolio, right? But among all the portfolios on the efficient frontier, right? This gives you the best return for risk, right? In other words, Sharpe ratio is the highest, okay? And Sharpe ratio is the slope. This we're talking about this, right? For any investment portfolio J, right? Sharpe ratio is Rj minus Rm divided by sigma, okay? Sigma of the portfolio, the risk involved with the portfolio, okay? So that's actually the risk premium. We'll talk about risk premium today, okay? So compared to the standard deviation, which is a measure of risk, it gives you the highest return, highest premium for the taking the risk, okay? Well, because the tangent point produces the greatest slope, right? So geometrically, you can understand why you achieve the highest Sharpe ratio at the tangent point, okay? So the important conclusion based on this is whatever level of risk you choose, you are willing to accept, you get the highest expected return from the mixture of M and risk-free lending, right? In other words, you can be on this line which connects RF to M and beyond, okay? And this is what we call capital market line. If you want, you can put 100% of your money in this portfolio, no borrowing or lending, right? Or if you can put 100% of your money on the bond, let's say a treasury bill, right? Which means you're not willing to take any risk. In that case, your risk level will be 0, right? Or you can do any combination of those, right? Or mixture of those, right? For example, if you put half of your money in the portfolio and half of money in the T-bill, right? Then you'll be right in the middle here, right? So that means you can expect about half the level of risk and half the level of return, right? Or if you really want to maximize your return, right? You can even borrow money, right? And double this portfolio, right? Then you can increase the return, but that means you are also accepting higher risk level, right? So the valid investment choices in this situation will always be found on this line, capital market line, right? There is no reason to consider any other portfolio inside here, because first of all, they are inefficient, right? There is no reason to consider inefficient portfolio, right? But even other efficient portfolios are not as good as the combination on this line, okay? So if you don't want to borrow money and maximize the return, then you can put 100% of your money in this portfolio. Or if you want to reduce the risk, then you can put some money in the T-bill, and you can be on this side. That means you're lending your money to the government, okay? Or if you want to really maximize your return at the cost of higher risk, then you can borrow money and be on here, right? So make sure you understand the concept of capital market line, okay? That's what we talked about last class. All right? All right, so today our main topic is beta. Somebody asked me about the beta last class, okay, which is a very important concept. Okay? It has to do with the systematic risk in the system. Okay? So we've been talking about diversification so far. And the idea of diversification is putting multiple of investment into one basket or one investment portfolio. That way you can reduce the risk while achieving certain level of return, right? But the type of risk that you can minimize or reduce based on such diversification is unsystematic risk. There are systematic risk and unsystematic risk, right? And we're talking about, this will illustrate the idea. Okay? The systematic risk comes from the systematic event, or those events that affect entire system. Okay? So something like the interest rate risk, you know, when the interest rate goes up, the entire stock market goes down. Okay? So systematic risk can be affected by the interest rate changes, okay? Or inflation. Pi stands for inflation. Okay? Something happens to economy, right? Then the entire inflation goes up, right? Then the inflation means the purchasing power of your money goes down. Okay? So if you get 10% return from your investment, if there is 5% inflation, that means your real return is only 5%, even though nominal return is 10%, right? So whether you have interest rate changes or inflation changes, these things will affect virtually all the stocks. Okay? So when all the stocks are equally affected, then diversification will do nothing. Right? You can't reduce the risk by investing in different stocks because everything changes at the same way and in the same way. Right? Another something like national debt. Many countries, including the United States, are suffering from the risk of national debt, right? National default on the government bond, okay? Or some political turmoil. Political turmoil like war or terror or something like that, right? And if those things happen, you know, entire market will be affected, right? So that's what we call systematic risk, right? So in this graph, we have a certain amount of systematic risk, right? And that systematic risk doesn't change depending on the number of securities in the portfolio, whether you invest in one stock or 5 stocks or 20 stocks or 1,000 stocks. Doesn't make any difference in the systematic risk, right? Because the entire system will be affected, right? Unsystematic risk are unique to individual company, right? Which means these risks are unique to individual company or maybe individual industry. Okay? Then something like management issue. If you have a bad management in a company, right, then the stock price may go down. Okay? Or cost, something like raw material. This particular industry or company uses, say, a lot of aluminum, right? Then if the aluminum price goes up, then the cost goes up, right? And that will squeeze the profit margin of the company, right? And it will negatively affect the company's stock price, okay? Legal and environmental issues. President Obama is trying to increase the pressure on this environmental issues, right? And he's facing a lot of opposition from the industry and also Congress people. But of course, a lot of industries use lobby, spend a lot of money lobbying the Congress people, right? So it's hard to enforce the environmental regulation, right? But those things affect the profit of the company, okay? And so on. Okay? I talked about BP oil spill, okay, last class or a couple of classes ago, right? So some disaster or accident occurs in one company or one industry, right? Then the risk increases, okay, because you will have fluctuation in the stock price, okay? So the unsystematic risk is something you can reduce by diversifying, right? Instead of putting all your money in one stock, if you invest in many different stocks or many different industries, right? So as the number of securities in the portfolio increases, so this unsystematic risk goes down, right? So the total risk goes down. Okay? That's the idea of systematic and unsystematic risk. Okay? Beta is a measure of systematic risk, or what we call market risk. Okay? So it shows the relationship between the stock price or return on one stock and the return on market portfolio. Okay? So beta is the covariance divided by variance, okay? And we learned this is the covariance and this is the variance. Okay? So M stands for market, J stands for one particular stock. Okay? Well, don't worry about this formula. Nobody uses this formula to calculate beta. Okay? Beta is estimated by using regression analysis, running the regression line. But just let's try to understand the meaning of beta. Okay? So here, in this graph, we're talking about rate of return on GM stock, General Motors, right? Starting from 1990, looks like 1990 is the earliest year. Starting from 1990 to maybe 2000, right here, 2000, 2004, right? So maybe the last 14, 15 years, right? So on the horizontal axis, you put the percentage return in market index. As the market index, we typically use something like S&P 500, right? Index, right? So if you, for your project, let's say June 1st, 2013, May 1st, 2013, April 1st, and so on, right? I think I'd show you how to calculate the monthly return using AT&T stock price, right? So this is new price minus old price divided by old price. So this in Excel, right? This number minus this number divided by this number, right? And that's going to be the return, AT&T return, monthly return, right? You can do the same thing with the S&P 500, right? So you find the S&P 500 index number as of June 1st, May 1st, April 1st, right? And you do the same thing, right? Then you can calculate the rate of return on the market index, okay? So you put the rate of return for the last 15 years here on the horizontal axis, and the GM return on the vertical axis. So we have these data points. So for example, in 1992, market return was about negative 3%, right? But GM produced about 13% return, right? That's what these data points are about, right? So the regression analysis, in case you haven't learned about regression analysis, is to find the best fitting line, right, through the data points, in order to explain the relationship between this variable and this variable, right? The variable on the horizontal axis and variable on the vertical axis, right? So what's the best fitting straight line, right? And I guess I can show you at this point how to do that before I forget, right? So, come on. All right. I have selected 4 companies, for example. AT&T, BAC is Bank of America. Yeah. Okay, AAPL, you know what that is. Okay, and PG is Procter & Gamble. You know, they produce a lot of household goods like soap and detergents and all kinds of, household chemical products mostly, right? So based on the adjusted close price, I calculated return, monthly return, right? And I put all 4 companies on one sheet, okay? So I have S&P return, ATT, BAC, Apple, and PG returns on these columns, okay? So first of all, let me show you how to calculate standard deviation, okay? You can use equal STDEVP. As you see here, there are many functions you can calculate standard deviation, right? But I want you to use standard deviation P. That means you're calculating population standard deviation, right? The difference between, if you just use STDEV in Excel, it's going to give you sample standard deviation, which is summation of xi minus x bar square n minus 1, okay? But you don't have to do that here. Here you have 36 observations for 3 years, right? So I want you to use entire 36 observations. So use STDVP. So that's the population standard deviation. Then Excel will calculate xi minus x bar square n, right, instead of n minus 1, okay? So STDVP, and just highlight the whole column, okay? Right, that's the standard deviation, and then you can just copy the formula all the way, okay? So you calculated the standard deviation for all 5 index numbers, okay? And then also you need to calculate the correlation coefficient, right, in order to do the project. So here you need to go to data analysis. Sorry about using the Korean version here, but you should say data analysis, okay? And among the choices here, there should be correlation. It should say correlation, okay? All right, and if you go to correlation, just highlight all 4 stock prices, including the label, okay? Do not include the standard deviation, right? Just include all 36 stock returns, right? And make sure you check this box for label, because you included a label, right? And you can specify where you want this output. Let's say, okay, hold on. I want it right here, okay? And click OK. All right, we got correlation coefficient matrix, correlation matrix, okay? All right. All right, so we have correlation coefficient between AT&T and AT&T is, of course, 1. That's why you have 1 all the way diagonal across here, right? And correlation between AT&T and BAC is 0.179. There isn't much correlation. What does that mean? What can you say? Correlation coefficient is 0.18. What's the story here? Not much? Okay. Yeah. Remember, correlation coefficient measures strength of linear relationship, right? So in terms of linear relationship between AT and BAC, Bank of America, the strength is very weak, I would say, right? It's pretty close to 0 rather than 1, right? And the correlation between AT&T and Apple is also very weak, right? And correlation coefficient between AT&T and Procter & Gamble is relatively weak, I would say, about 0.27, right? Correlation coefficient between BAC and Apple, Bank of America and Apple, is it's okay. I guess it's about, how can you say, moderate, okay? It's not strong. Typically, if the correlation coefficient is close to 0.8, you can say it's pretty strong, right? 0.8, right? If it's 0.2 or 0.3, you can say it's rather weak, right? Anything in between 0.2 and 0.8 can be moderate. You can say it's moderate, okay? Anyway, so we got this correlation coefficient between all 6 combinations, right? 1, 2, 3, 4, 5, 6. Because you have 4 companies, right? You should have 6 combinations. So you can have 6 different portfolios, right? But 4C2 or 2C4, 4C2, right? Selecting 2 out of 4, right? So that should be what? Something like 4 factorial, 2 factorial, 2 factorial, right? So that should be 6, right? So in your project, you're supposed to come up with portfolios of 2 stocks in each portfolio, right? Out of 4 possible choices, right? So you can examine 6 different portfolios here, right? All right. Anyway, so that's how you calculate the correlation coefficient, right? How do you do the regression? Okay, here we go. Go to data analysis, and here we have 회귀 분석. In English, it should say regression analysis, right? Regression. Click here. Y variable is your individual returns. So if you want to calculate beta of, say, PG, right? Then just highlight this PG, including the label. Do not include the standard deviation, okay? That's your Y variable. X variable, what should we do? Huh? S&P 500, right? That should be your, okay. All right. And then make sure you check the label because you included the label, right? And then you can choose where you want your output. Let's say new worksheet, okay? And all the rest you don't need. Just click OK. All right. So here we go. We got the output, right? All you need to use here from this output is this number, right? The coefficient for SN. What the? It should say PG. Why does it say S&P return?
Maybe it's.
What did we do? Let me go back to sheet 4 here and go back to data analysis. Okay. Yeah, I guess this is right. Okay. Because in typical regression, y is f of x, right? So if you have a plus bx, the Excel is calculating this coefficient, right? So that's why because we set X as S and P, right? Okay, okay, it makes sense, right? It makes sense, right? Right. So you should see S and P on the X, right? Because after all, what we are doing is here in this graph, right? What we are trying to find out is the slope, right? And if the slope comes out to be 1.5, let's say, right? Suppose beta came out to be 1.5, right? What that means is this vertical change, the rise is 1.5 every time the horizontal change is 1, right? What that means is that if the S&P 500 index increases by 1%, then the return on this particular stock increases by 1.5, right? Okay? All right? So that makes sense, right? So it can be a little bit confusing, but make sure you understand that, right? So when you look at the output, you should have S&P 5 returns here, and this number is beta. So beta came out to be 0.35. Someone interpret that for me. 0.35. What does that mean?
If S&P increased by 1%, then the PG increased by 0.35.
Right. We're talking about returns, right? So if the market returns, on overall market returns improve by 1%, you can expect Procter & Gamble return to increase by about 0.35%. Okay? Make sure you understand how to interpret the beta. Okay? Is it possible to have greater than 1? Yes. In this case, it is possible, right? So if it's, let's say 2, beta came out to be 2, then that means whenever market return goes up by 1%, the return on this particular stock will increase by 2%, right? What if market goes down by 1%? Right, because we have positive 2 here, right? We have positive correlation, right? So whenever this increases, this goes up. Whenever this goes down, then, right, the return on particular stock goes down, right? So but the thing is, it's twice as much, right? So if the market return goes down by 1%, you can expect the return on that particular stock to go down by 2%, right? In other words, this is telling you that return on that particular stock is twice as volatile as the market return, overall market return, market portfolio. Okay? So that's how we calculate the beta and how to interpret the number, beta number, right? And so beta measures the volatility here. So again, maybe you want to remember this concept, that don't worry about using this formula. Nobody uses this formula, right? So beta can be 1. If beta is exactly 1, what that means is volatility of this particular stock is exactly the same as market return, right? So whenever market improves by 1%, you can expect the market, this return on particular stock to increase by 1%, and so on, right? It can be greater than 1, negative 1, less than 1, or negative, actually. What does that mean if beta is negative? Right. So what that means is this regression line is downward sloping. It has negative slope, right? So when the market goes up, then the return on this particular stock can actually go down, right? Is it possible? Yeah, I think we talked about something like gold last class, right? Gold mining stock, right? I think in investment they call it contrarian contrarian stock, okay? Which means this particular stock moves in the opposite direction from the market. Okay? Well, if you can find the contrarian, it's a good stock to use to diversify your risk, right? Okay? All right. So here's some summary. Regression line of periodic in the market index, right? So beta is estimated by obtaining the regression line, okay? And that line is called also a characteristic line, right? So this regression line here, in this situation, if you are doing two returns, right, can be called the characteristic line, right? And beta is the coefficient of the return on the market index, yeah, and it is regularly published by security analysts, yes, right? So okay, all right. Okay. Can you just read it? I made slight changes in a couple of graphs here. If you compare this graph to what you have in your note, I have added a few things here, right? So I have printed those graphs out, okay? Since beta measures the relationship between the risk of a particular stock, the risk of a particular stock and the market risk, the risk premium can be calculated. The risk premium can be calculated based on beta and the level of market risk. In case you are taking the picture of this, I haven't uploaded the link of this video recording a few weeks because I found out now it's working. If you go to the Hanyang portal and go to this class, right, and click on lecture, all the video recordings are automatically uploaded based on the lectures, I mean the date of the lecture. So you should be able to watch the recording, no problem. You don't need the link from me. It was supposed to be that way from the beginning of the semester, but it took some time. Okay? So let me know if you have any trouble finding the video. Okay? Okay. So what does that mean? Okay? Well, so we are being introduced to another line here. We're talking about so many different lines. We talked about capital market line last class, and this, what was the name of this green line? Characteristic line, right? And now we're talking about security market line. Okay? They are all slightly different. Okay? Security market line is the relationship between expected return and beta. Right? So you have beta on the horizontal axis, right? And the expected return here, right? So here, one thing you have to understand, tell me, can you find the slope of this red line or security market line? What's the slope from this graph? RM minus RF, right? Why? You know why, okay? Because the slope of this red line is if I draw a line here, let's say, okay, and let's see, suppose I drew the line like this. It's a little hard to see, right? But then this height is RM hat minus RF hat, right? But the bottom, the run is 1, right? So the slope of this line is exactly RM minus RF, right? Okay? So let me first write it down. RM hat minus RF hat, RF is the slope of security market line, okay? And then for any stock or any portfolio with a certain level of market risk, be beta J, right? What is the required rate of return for that security, right? We can find that out, right? So, well, because we know this is a security, if this is a security market line which shows the relationship between expected return and beta, right? Then R J hat, which is expected return from any particular stock or portfolio, right, should be RF hat plus RM hat minus RJ, or RM minus RF times beta J. Okay? Because, I'm talking about this, right? Let's say D Y is 2 plus 3x. Okay? Then if you have x value of 4, right? And you can find this out, right? If you plug in 4 here, right? And the y should be what? 14, right? 2 plus 3 times 4, right? That's exactly what I'm doing here, right? So because the slope is Rm minus Rf, right? The Rj hat is simply Rf plus the slope times beta j. Okay? Does it make sense? Okay. All right. Well, in the beginning of this chapter, I gave you an equation, right? Something like Kj is Rf plus sigma j. Not sigma, theta j, right? And at that time, I told you this is risk-free rate of interest, right? And this is risk premium. Risk premium. Okay? So this is risk premium, right? In other words, if this portfolio had absolutely no risk, right, then required rate of return would be exactly risk-free rate, right? But because we are dealing with some market portfolio or particular stock in the market, right, J, right, whatever, right, that requires this much additional risk, right? So this is risk premium. Sorry about my writing. It's hard to write on chalkboard. I used to write the whiteboard. It's so smooth. Right? I have to use my arm here. Right? risk premium. Okay. And this one inside here, okay, this one, this is actually called the market premium. Okay? Because that's the difference between the market portfolio and risk-free portfolio, right? So that's the market premium. And if you multiply market premium by the beta, you get risk premium, entire risk premium. Okay? Or market risk. Okay. I can say this is market risk. All right? And you know what we're talking about here, right? Okay, so based on that, now we're getting to our last, the next graph. Okay, here we go. Yeah, I noticed that the one you have on your note is completely different. It says figure 6.15, right? That was actually from the previous version, 6th edition, right? And now we are using what? 12th edition? No, I'm sorry. That was from 11th edition when this chapter was chapter 6. Now it's chapter 8, and I noticed there's a slight difference here if you compare this part, right? So I gave you the new graph there. Anyway, here we go. So the story of this graph is this, right? There are two different portfolios, A and B. Okay? Or you can say A and B, two different stocks or whatever. Two different investment, A and B, right? And which one is better or which one is acceptable, right? You can say that based on this security market line. Okay? Remember, this is security market line because you have beta on the horizontal axis and returns on the vertical axis, right? So if the green line is security market line, and we have the equation here, Kj is 6 plus 8.1 beta j, right? So what is the risk-free rate? 6%. What is the 8.1? Market risk, which is Rm minus Rf. Okay, good. All right. So now we have this equation. Based on that, think about it. If you have any portfolio or investment which has exactly 1 for beta, right, then what is the required rate of return? Well, you can plug in 1 here, right, for beta, right? And that's going to be 14.1. That's exactly right here, 14.1, right? So that's the required rate of return because on average, that's what you can expect from the investment, average investment, right? But this particular investment A has the same market risk or systematic risk because beta is 1. But it promises 16% return, right? So what do you think? Is it good or what? That's good, right? Because that's the return on that particular investment is above the required return, right? What about investment B? That's the different story, right? Because apparently this investment B has 1.5 beta, right? Which means whenever the market goes up by 1%, it goes up by 1.5%, right? But the other side is whenever market goes down by 1%, then this investment goes down by 1.5%, right? So it is more volatile, which means it's riskier, right? It has higher risk, right? And for that much risk in the market, you would require 18.15% return, right? According to this calculation, if you plug in 1.5 here for beta, right, you will get 18.15. That's the required rate of return, right? But apparently this investment B's return is only 17%. Okay? So you can say that's unacceptable compared to the risk. Return is too small. Okay? So what that means is if you find any combination, any portfolio or investment above the line, what can you say? Yeah, those investments are acceptable or attractive, right? If you find any investment below the line, then you should not put your money because there are better choices available, right? In the worst case, you can put your money in index fund. There's what's called S&P 5 index fund. Why do you laugh? You think it's too boring? Right? Index fund means the money managers put the money in all those companies in the index, like Dow Jones Index or S&P 5 Index, right? So your return will be exactly the same as market return. If the Dow Jones goes up by 10%, then your return will go up by 10%, exactly, right? But if you look at the history of Dow Jones, I don't think you would laugh, right? Dow Jones return went up at least 15 to 20% it last, let's say, so many years, right? So it'll probably be very difficult to beat the Dow Jones Index Fund. I have most of my retirement fund in Dow Jones Index Fund, and I'm happy these days. Just somehow, if there is a good news, it goes up. If there is a bad news, it goes up, right? For some reason, right? Somehow investors just, yeah. Okay. So, finally, we are coming to the capital asset pricing model. Okay? And that's nothing but the equation of SML, okay? Security market line. Okay? So as you see here, did you get some weird characters here in your note? I think it has to do with the Korean font, right? Yeah, so I changed it, I copied it from the textbook. Okay? But you have all these equations in your textbook, so I'm sure you can find out. Okay? All right. So as you see here, this is nothing but the security market line, right? Required return is risk-free return plus beta times market risk. Okay. So using this equation, you can calculate the required return, right, for any security J. Yeah. And also, for some reason, I think our textbook misses it, right? Portfolio beta. Portfolio beta. So beta portfolio is nothing but weighted average of each individual stock. So you can say WJ beta J. J goes from 1 to N, I guess. Right? Portfolio beta is simply the weighted average of individual beta. So if you have two stocks, say A and B, right, and you got 60%, 40% weight in two stocks, okay, and the beta of stock A is, say, 0.8, and the beta for stock B is 1.5, right? Then the portfolio beta is simply 0.8 times 0.6 plus 1.5 times 0.4, right? That's how you calculate portfolio beta, right? I think you need this for the last question Well, actually, before that, I mean, for your project, you need, in order to find the efficient portfolio, you have to, well, okay. Anyway, I think you will need it for you somewhere in your project. Okay? Somewhere in your project, you will need to calculate portfolio beta. Okay? Okay. All right. So risk premium, here's a kind of summary, right? Market risk premium is RM minus RF. Risk premium for security J is beta J times RM minus R. If you have any weird character, make sure you change it now. Okay. Okay. And the slope of the security market line is the market risk premium. Yeah, we talked about that, which is simply this, right? RM minus RF, right? Okay. And slope will increase or decrease over time. Yeah. Well, because, sensitivity of stock return on the market return changes, right? There's no reason why it should stay the same. Okay? All right, so here's the last slide. CAPM and security market line, right? And it's just an example. So here in this example, risk-free interest rate is 6%, okay? And let's say market return, RM, happens to be 9%, right? Then the risk premium is, or market risk premium is 3%, right? I should have said market risk premium here, right? Market. Okay. Okay. And then you can calculate the required rate for any portfolio A, right? Or any investment A. That's 6% plus 1 point, because here's a particular investment which has 1.5 beta and 10.5%. Well, that's how we calculate it, right? So what's the required return on any investment which has 1.5 for beta, right? And you can calculate it this way, right? And we find out that's 10.5%. And that's how we use CAPM, right? CAPM equation. Questions? Any question from the project?